Welcome to the Unit 1, Section 1 video on arithmetic sequences. So before we start talking about what arithmetic sequences are, let's start off with this simple example. Let's say that the price for a gallon of gas is $3.05. Well, what I've presented for you here is a table of how much it costs if you get a certain number of gallons of gas. So for example, if you were to get 5 gallons of gas, it would cost you $15.25 at a price of $3.05 a gallon. If you were to get 10 gallons of gas, it would cost you $30.50. So what I have done here is I have essentially gone through and plotted this table on this graph. And what you can see here is as we plot each data point for each gallon of gas, that being along the x-axis, and the price that you pay per gallon, that's along the y-axis, we have a value for each of those gallons of gas, a certain number of gallons of gas. Well, when you look at all these points plotted, what kind of figure do you think you would have? Well, what we end up with is simply a line. Okay, so since we have a line, that is what you would get if you were to connect all the dots of the graph. What kind of equation does this represent? Well, since it's a line, you would have a linear equation. And we know how to work with linear equations already. We've already talked about slope and y-intercepts and things like that, and how we can figure out different values along a certain line if we are presented with a linear equation. And that's a lot of what arithmetic sequences are about. Okay, so as we move on down here, the set of gas prices in successive gallons that I presented in that graph is an example of a sequence. And each number in the sequence is called a term. Okay, so our 1 gallon of gas price, that would be a term. Our 5 gallons of gas price would be another term. Okay, and they are all terms in the sequence. We have a sequence of 1 gallons of gas, 2 gallons of gas, 3 gallons of gas, 4 gallons of gas. Okay, and then each of those terms has a value attached to it, which is the price. Okay, so the first term in a sequence is symbolized by a sub 1. Okay, so our 1 gallon of gas would be our a sub 1 term. The second term would be symbolized by a sub 2. So 2 gallons of gas, that price would be a sub 2. And so on to however many terms you have, that would be a sub n terms. And that would be the representation of your nth term, or the value for your nth term. So the sequence in that chart above contained 10 terms. We had a sub 1, which is our first term, being $3.05 a gallon. And then we had our last term in the table, which was a sub 10, being $30.50. Okay, and of course we had a sub 2, a sub 3, a sub 4, everything going on in between as well. Okay, so let's now talk about what kind of a sequence this is specifically. This sequence that we have, because it's linear, is called an arithmetic sequence. And it's called an arithmetic sequence because each term in the sequence can be found by adding $3.05 to the previous term. The number to find the next term of an arithmetic sequence, in this case $3.05, is called your common difference. And the common difference is symbolized by the variable d. Okay, so here I just give you a definition of what an arithmetic sequence is. An arithmetic sequence is a sequence in which each term after the first is found by adding a constant called the common difference to the previous term. Okay, to find the next terms in an arithmetic sequence, all you have to do is find the common difference d by subtracting any term from its succeeding term, and then add the common difference to the last term to find the successive terms, okay? So if we're given just a little bit of information, we can build a sequence out because of how an arithmetic sequence is structured. It has a constant difference between each term, which is our common difference, and that can in turn be thought of as beta slope when you graph it on a line. So let's just do a couple of examples to get us used to how to find a common difference, okay? There's nothing inherently hard about it, okay? Let's look at the difference between -3 and 2, okay? So if we were to do 2 minus -3, so our succeeding term minus the previous term, we would end up with a difference of 5. If we were to do that between 2 and 7, we'd end up with 5. If we were to do that between 7 and 12, we'd end up with 5. And between 12 and 17, again, we'd end up with 5. Okay? So for this particular sequence, at least with the information that we were presented with these 5 terms, the common difference would be 5. Okay? And we can notate that as d equals 5, because d is our variable representing common difference, d for difference. Okay, so we want to find what the next term is. Well, if we want to find the next term, all we have to do is simply take the last term in the sequence that was given, 17, and add our common difference, 5, and so we find that our next term is 22. All right, let's look at this next example. We're given this sequence. We want to find out if it's arithmetic. Well, let's see. 12 minus, or I should say -12 minus -4. Well, that's going to give us -12 plus 4, because we had a minus, and that gives us a difference of -8. Then we go to -24 minus -12, so -24 plus 12 gives us -12. And we can actually stop right there, because we have 2 different values for the difference in our sequence, which means that this is not an arithmetic sequence already. I'll go ahead and give you what those other differences are, just so you can see the more complete picture. But since we do not have a constant common difference, then therefore this sequence is not arithmetic. Okay? So now, let's talk about formulas for arithmetic sequences. Okay? We want to represent arithmetic sequences a certain way. And to do that, we are going to use a couple of different types of formulas. The first of which is called a recursive formula. And it's called a recursive formula because it depends on knowing a little bit of information about the sequence already. It's a formula for a sequence in which one or more previous terms are used to generate the next term. So you already need to know what some of the terms are in the sequence to be able to generate the next terms. Very similar to how we found the next term in that example above. Okay, we'll talk a little bit more about recursive formulas here in a moment. Let's talk about what the other one is. The other one is going to be your explicit formula. And your explicit formula is a formula that defines the nth term, a sub n, or your general term, of a sequence as a function of n. And it can be written in terms of x and y. Essentially what you're going to end up with using an explicit formula is the equation of a line, that line representing what our sequence is, since our arithmetic sequence is a linear function. So let's talk about recursive formula. This is what it's going to look like. The nth term of an arithmetic sequence is given by a 2-line kind of formula here, okay? So this formula is going to have 2 lines in it. The first line is going to tell you what your a sub 1 term is. So a sub 1 equals whatever that value is for the first term. Then a sub n equals a sub n minus 1. A sub n minus 1 represents the term preceding a sub n plus our common difference. Okay, so the only 2 pieces of information you need to be able to construct a recursive formula is what the first term is in your sequence and what your common difference is. If you have those 2 pieces of information, you can construct a recursive formula. Now for an explicit formula, since we know an arithmetic sequence is linear, we can write the sequence as a linear equation. So here's what I've done here. I've given you two lines, you're only going to use one of them as your answer for an explicit formula, and that would be your y equals mx plus b. That's your slope-intercept form that you are fairly familiar with. Well, this is what each thing is when we're talking about arithmetic sequence. Here's what each thing represents in that type of formula. So your y is your a sub n. That's your value for your term. Okay, if you remember back to the example that we started with, that's what our gas price is for however many gallons we are purchasing. Our m is our slope. Well, that's our common difference. So if you know the common difference, you know the slope. Our x value is going to be our n, so that's our term number. And you'll notice that's given in a sub n. So if you're looking for a sub 1, then your x is going to be 1. If you're looking for a sub 25, then x is going to be 25. And then your y-intercept, b, is going to be your a sub 0 term. Okay, so it would be whatever term would precede the first term. That would be your y-intercept. Let's go back to that example at the beginning and kind of get an idea of what the y-intercept looks like in terms of an arithmetic sequence. Okay, so if we look at this graph, okay, we've got the x-axis, which is our n. We have our y-axis, which is our a sub n. Well, if we have our first term being our first gallon of gas and the price that goes with it is $3.05, well, if we want the term before that, we subtract our common difference, right? And if we subtract 305 from that first gallon that we got, that was 305, we end up with 0. And it looks like it would go through the origin here, right? This linear function would go all the way back to 0, 0. And that makes sense, doesn't it? Because if you purchase 0 gallons of gas, you're going to pay $0. Okay, so that kind of gives you an idea of how that works with the explicit formula. Your y-intercept is the term preceding the first term. And again, to find that, you simply take your first term and subtract your common difference. Okay. Well, we need a couple more things before we start moving into actually constructing some formulas in these examples that are to follow. To find the explicit formula, you need to have one term in the sequence. So you need to have one term, and you need to have the common difference. So if you have one term and you have the common difference, then you can construct the explicit formula. And you can do that using the point-slope form of a linear equation. So you're going to use point-slope form. And I presented that here for you down here, okay? Point-slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. Your y sub 1 and your x sub 1, they are going to come from your term, okay? And then your slope, m, will come from your common difference. Your y without the subscript and your x without the subscript are going to remain as part of the equation because you're going to get something that looks like y equals mx plus b. And you'll see that here as we do these examples. So let's get into doing some examples of constructing these equations. We can create a formula to find any term of an arithmetic sequence if we know either the sequence itself, a random term, and the common difference, or if we know two terms. And we're going to go through how to do each of these. Okay? So let's start off with this example of finding a recursive formula, an explicit formula, and the term that they ask for using the sequence that's presented. Okay, so we're going to start with the recursive formula when we have a sequence. So our sequence is 32, 37, 42, and 47, and it goes on from there. Well, the first thing we need to do is find out what our common difference is. Okay, and I'm just going to notate that as D. Well, let's see if we have a common difference. 37 minus 32, that gives us 5. 42 minus 37 gives us 5. 47 minus 42 gives us 5. So it does appear with the sequence that's given that we do have a common difference, okay, when that common difference is indeed 5. Okay, well now we have everything we need to do a recursive formula, because remember, for a recursive formula you just need to know what the first term is in the sequence, which they give us at the beginning of the sequence. So that is a sub 1 equals 32. And we need to know what the common difference is. Well, that's 5. So we can just lay that into the second part of our equation and put plus 5 in for our common difference. So this entire thing, both of these lines that are presented right here, this would be your solution for the recursive formula. Okay, remember the recursive formula is going to be 2 lines, and your first line is going to give you the first term, the second line is going to give you a general formula for finding any term using your common difference. Okay, now that we know the recursive formula, let's go on to the explicit formula. All we need to do the explicit formula is a term and the common difference. Well, we know that the first term, a sub 1, equals 32. So we'll just use that for the term. And what information that gives us is our x, which is 1, because a sub 1 tells us it's the first term, and our y, which is 32, which is the value that goes with our first term. Then we know that our common difference is 5. Well, that just tells us what our slope is. So now all we have to do is use our point slope form. So we have y minus y sub 1 equals m times the quantity x minus x sub 1. I encourage you to write this every time you go to plug things in, because it helps you remember the formula, and it also allows you to kind of see visually where you're plugging things in. So we have y, that stays, minus y sub 1, which in our case is 32, times m, which is 5, times x minus our x sub 1, which is 1. Now this left-hand side is going to stay the same. We're going to distribute out this 5, so we have 5x minus 5, and then we're going to add 32 to each side. And we get y equals 5x plus 27. And that is going to be our solution for the explicit formula. Okay? Now the last thing that they ask us to do is define the term A34. Okay? This is where having formulas is handy, because we could just keep adding 5 and we just do it about 30 more times or so, and we'll eventually get to what that is. But if we have a formula, we can find what that term is a little bit faster by starting with the formula that we just found, our explicit formula, y equals 5x plus 27. And then if we just take our A34 and plug it in, so A34 would be our y. That's the representation for the value for that term. Our x is 34, okay, because it's the 34th term. And then plus 27 on the end. And now we just simply do the math. And if you do that math, you're going to end up with a sub 34 equals 197. Okay? So if you were to keep adding 5 for each term and build this sequence out, by the time you get to the 34th term, you would end up with your value being 197. And that would be the third part of your answer for this. Okay, so that's the first way. We have just found the recursive formula, the explicit formula, and a term that was requested for a sequence. Now let's move on to when we're given a random term and the common difference. Well, in some ways, this is actually a little bit easier problem to do. Because we are given the common difference up front, we can go ahead and take our term and our common difference and find the explicit formula. So we know that a sub 40 equals negative 165. What that tells us is we have a point that is x equals 40 and y equals 165, or negative 165. All right, our common difference being negative 5, that tells us our slope is negative 5. And so now we're just going to drop this into point slope form. Y minus y1 equals m times x minus x sub 1. And when we do this, we are going to have y minus a negative 165 equals negative 5 times the quantity x minus 40. Okay? On the left-hand side, we end up with y plus 165. We distribute the right-hand side, so we get negative 5x plus 200. And then we subtract 165 from each side. And that gives us plus 35 on the end. And this would be your explicit formula. Now we can move on to our recursive formula. Okay? So with our recursive formula, we can start off with our explicit formula that we just found, because we have the common difference, but what we don't have is what the first term is. But we can find the first term using our recursive formula, because our recursive formula can be used to find any term. So y being a sub 1 equals negative 5 times 1 being the first term plus 35. And then when you do that math, you get a sub 1 equals 30. And our second line of our recursive formula, our second line of our recursive formula is going to be a sub n equals a sub n minus 1 minus our common difference, which is 5, or plus our common difference of negative 5, which gives us negative 5 or minus 5 on the end. Okay, so this would be our recursive formula. Again, recursive formula is going to have 2 lines as part of that formula. Okay, so now let's move on to the last type. Okay, well, when we are given 2 terms, we can find the explicit and recursive formulas, but there's one additional step that we have to do first. And that is we need to find what our common difference is. Now remember, this is a linear function, so our common difference is slope. We've already talked about that in the last 2 examples. We've used common difference as our slope in the point slope form of the linear equation. Well, let's recall what the formula is for average rate of change, or in the case of a linear function, the slope. We have change in y over change in x, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you can use that to find what your slope is, which would be your common difference. So let's do this in example 5. Okay? So in example 5, we want to find the recursive formula and explicit formula for an arithmetic sequence where a sub 19, or our 19th term, equals 10, and our 36th term equals 44. All right, to find the common difference, we're already given with our y sub 2, y sub 1, x sub 2, and our x sub 1. Because we have 2 terms, we have 2 points to work with. A 19 equals 10. Well, that's just another way of saying we have x equals 19 and y is 10. And then a 36 is 44. That means our x is 36 and our y is 44. Okay? So we're just going to use those for our x sub 1, x sub 2, y sub 1, y sub 2, okay? So we have change in y over change in x is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Not a bad idea to write out the formula each time. Again, it helps you with plugging things in. It also helps you remember the formula. So let's say y sub 2 is 44. Let's say y sub 1 is 10. Okay? Let's say x sub 2 is 36, because that goes with y sub 2. And then x sub 1 is 19. All right, so when we do this, we end up with 34 divided by 17, and that gives us 2. So 2 is going to be our common difference. Well, now we have a point where we have a term, which gives us a point. A sub 19 equals 10 is 1910, as we just said. And you can use the other one if you want, but we only need one of them. Our common difference, as we just found, is 2. Well, that's our slope. So now all we have to do is go into y minus y sub 1 equals m times x minus x sub 1. Y minus our y sub 1, which is 10, equals our slope, 2, times x minus x sub 1, which would be 19. So we just do a little bit of quick math. Y minus 10 equals, do some distributing, 2x minus 38. And then we have, adding 10 to each side, y equals 2x minus 28. And that is our explicit formula. And now finally, if we want the recursive formula, all we have to do is use our explicit formula that we just found to find what our first term is. A sub 1 is going to be 2 times 1 minus 28. And you do that math and you find that a sub 1 equals negative 26. And then our second line is a sub n equals a sub n minus 1 plus our common difference, which is 2. And that gives us our recursive formula, again, that formula being 2 lines long. Okay, so this wraps up this section where we talked about arithmetic sequences, how to find the recursive formula, how to find an explicit formula. If you're given 2 points or 2 terms, how do you find the common difference? So these are things that we can work with. And of course, the more practice you get with problems like this, the easier they become. You start to see how they work and how the explicit formula and recursive formula work together. Okay, coming up in section 2 of Unit 1, we are going to be moving on to compound inequalities.